Good morning, guys. Yeah, good morning, everyone. I hope you are able to see my screen.
Yeah.
Yeah, thank you. So let's quickly look at what we have learned yesterday. So yesterday we looked at the bubble sort with the optimized technique, right? So if the given array is already a sorted order, we don't need to sort it for the many number of times, right? By writing this single flag, boolean flag equal to false, and making the flag equal to true, and we can write this is I can write it as a optimized bubble sort, right? Yeah. Today what we are going to look at is the selection sort. Now let's look at the algorithm for a selection sort first. So let us take some input elements. Yeah, 14, 10, 56. 14, 10, 56. There is no guarantee that these numbers are only we should take. You can take any numbers. These are the best numbers I can explain you, so that I am taking 1, 4. Okay. Now what does the selection sort will do is, selection sort is opposite to the bubble sort. When I say opposite, in the bubble sort, in the first iteration, what is the output?
Largest element.
And in the second iteration?
Second largest.
Yeah. That means, can I say that you are sorting from last to first?
Yes.
Yeah. So similarly, when it comes to a selection sort, you are sorting from first to last. That means, what do you think? In the first iteration, what do you think?
Minimum value.
Minimum value. So when I say that I am sorting from first to last, means so whenever you say sort, it's a ascending order. So it's ascending means in the starting position, or that means in the 0th position, lowest value of the array should be present. So the way we do this algorithm for selection sort is, first we assume in 0th location or index, assume in 0th location or index, the value present is the smallest value in the array. First, I am assuming, like, what is the now here? If you take 0th index, what is the value? 14. Okay, that means, can I say this 14 is nothing but a of 0? Agree? Now I am assuming, I mean, first time it is not the smallest, but whenever I'm starting, I am assuming that in this a of 0 is the smallest value in the entire array. But when do I know whether it is smallest or not? I need to compare with the rest of the array, correct?
Yes.
Yeah. Then compare a of 0 with rest of the array, and try to find the index at which minimum value of the array is present, and then replace with 0th index. Don't worry, I will explain this one. Okay. Now, so as I mentioned first, we are that I'm talking about a first iteration. Since it is a first iteration, I'm taking a 0th index. Now, first I'm assuming the minimum value is present at 0th index. What is that? That means a of 0 is the minimum value I'm assuming. Okay. But is it a smaller or not? How do I know? I need to compare. Now, then compare a of 0 with the rest of the array, and then try to find out an index at which minimum value of the array is present. Now, once I got it, now what I need to do? Compare this 14 with all other elements, and try to find out an index at which you're not finding out a value, you are trying out to find out an index. in which index you have the minimum value of the array. This is the important thing. You are trying to find out a index at which minimum value of the array is present and then swap it. Now, so now what is, you need to compare 14 with a 10. So 10 greater than 14. Is it true?
No.
No.
No. So that means can I say, what is the first assume, what you assumed? You assumed whatever the value that is in the 0th index, which is 14, is lesser than, it's the smallest element. But can I say it, first index, you got the smallest element now? Am I right? So first we thought A of 0, 0th, in the 0th index, whatever the value is there, that is the smallest I assumed, correct? But is it a smaller?
No.
No, after comparison with a 10, see, in this two, which is the smaller value?
10.
And 10 is present at what index?
First
A
Index
of
1.
1.
Index 1, correct? Now, instead of comparing with 14, can I say now I have to compare 10 with the rest of the array, correct? Now, compare with the 10 and 56. 10, sorry, my mistake. Let me write like 10 greater than 14. Now, sorry. You can, I mean, you can do the comparisons, whether it's a greater than or less than. So my aim is to find out, compare this A of 0 with the rest of the array and try to find out a value at which the minimum value of the array is present. Okay. Now, so A of 0 is 14. Now I am comparing 10 less than 14. Is it true? If it is true, what does it mean? Whatever you have selected, this value is bigger than this value, correct? Now, I will change the min index equal to, what is the first I thought? Minimum value of the index is 0th index. But after doing the comparison, is 14 is a minimum value?
No.
No. That means now first what I assumed? I assumed that whatever the value that is present in the 0th index is the smallest value. But after comparing this A of 0 with A of 1, at which index the minimum value of the array is present till now? First index, correct? So I will change the min index equal to 1. Okay. Now let's compare. Now first index, whatever the value that is present, that's the minimum value at this present. Now first index. Now what is the first index? 10, right?
Yes.
Yeah. Now compare this with the rest of the array. So 56 less than 10. Is it true?
No.
That means still whatever the value that is present in first index, it says still the smallest element, correct?
Yes.
Yeah. Then if it is not, I mean, if it is true, then you need to change it. Now let's go to the next one. 1 less than 10. Is it true?
Yes.
Yeah.
1 less than 10, it is true means what? Now, at what is the index of 1? 0, 1, 2, 3. Now, can I say, I mean, whenever you are doing a comparisons, you thought first index is having a minimum value. But after continuing the comparisons, can I say in the third index you have the minimum value now?
Yes.
Yeah.
Yeah. What is the value of the third index? 1, correct? Now your min index is what is the value? Index 3. Yeah. Now 1. Now let's continue. 4 less than 1. Is it true?
No.
No. That means, can I say I have completed the comparisons?
Yes.
I have reached the end of the array. Now, after doing the comparison, in which index you found the minimum value?
Third
In the
index.
entire array, you found the minimum value in a third index, correct? This is the one, correct? This is the index that you found minimum value. Now, you tell me what is the right position for this? Where should I place this one? When you do sorting, minimum value of the array should come into what position?
0 position, index 0.
So that means, so we will swap this one with this one with this one. So that is what I have written here. Compare A of 0 with the rest of the array and try to find out an index at which the minimum value of the array is presently. By doing comparisons, can I say I found out an index? What is that index? Index 3. At index 3, the minimum value of the array is present. And then replace with 0th index. Why am I doing replacing with the 0th index? Because the smallest value, the right position for a smallest value after doing a sorting is 0. So now my array looks like 1, 10, 56, comma, 14, comma, 1. See, I am swapping. Right? And comma 4. Correct? This is my array. Right? Now, if you look at, can I say this is sorted now? See, am I
Yeah.
sorting from starting? Yes.
Yes.
Now, but the rest of the array is sorted?
No.
No. I have to do, see that this is nothing but a first iteration. First iteration. Now let's continue the same iteration. Now in the first iteration, whenever I'm starting, which index I took it? 0th index is the minimum value, correct? Now, should I start with the 0th index again in the second iteration?
No.
Because it's already sorted, right? You are doing the sorting from starting. You can ignore this. Now, what should I do? I'll assume that index equal to 1. That means whatever the value is present at index 1, that is the minimum value I'm assuming. So that means 10. Now, 56 less than 10, is it true?
No.
No, that means till here, I mean, within these two numbers, 10 is the smallest. Yes. Now next, 14 less than 10, is it true?
No.
No. Next, 4 less than 10, is it true?
Yes.
That means, where is the now next, whenever you are doing, what is the minimum index at which the second minimum value is present? 0, 1, 2, 3, 4. Correct? Fourth index. Let us take the value as different value, guys. So instead of 4, let us take the different value, because index is 4, this one is 4, right? You will be confused. Now, after doing the comparisons, you tell me which index, at which index minimum value is present? Fourth index, correct?
Yes.
Minimum value is present. Now, what is the right position to keep this?
First index.
Yeah, first index.
First.
Yeah. So that means here, can I say now here, in the first iteration, you are replacing with a first minimum value with a 0th index, correct?
Yes.
Now, if I start with I equal to 0, now I am replacing with 0th index. Now, if I take I equal to 1, this is the first iteration, then I am replacing with first index, correct? That means, can I say, generically, can I say, after finding out at which index the minimum value of the array is present, then replace with ith index, correct? Instead of 0, every iteration you have to replace. So now I have to replace this 10 with a 14, correct? My array looks like this one. Now 1, 5, 56, 14, 10. Now can I say this is my iteration? Now if you look at 1, 5 is sorted or not?
Yes.
Yes.
Now should I continue or should I stop it?
Continue remaining.
Yeah. Now what would be my minimum index? Where should I start?
Second index.
Yeah,
2.
I will assume that whatever the value that is present at second index, that is nothing but a 56. 56 is the smaller value, correct? Now, 14 less than 56, is it true?
Yes.
That means, is the 56 is a no longer a smaller value, correct? Now you take this one, okay? Now, 10 less than 14, is it true?
Yes.
That means this is a smaller value. Now this has to be replaced with 56, correct? Now this is the third iteration, 1, 5, 10, 14, 56. Now if you look at here, can I say this is sorted? And the entire array is also sorted, correct?
Yes.
So this is about a selection sort. In the selection sort, we are sorting from starting to the ending. Now, where can this be useful? If someone is asking you, they are giving you 1,000 numbers and they're asking you 10th minimum value. Do you need to sort the entire array? Not required. How many times you need to iterate? 10 times only, correct?
Yes.
Yeah. So the basic thing is, first we are assuming ith position is the minimum value and do the comparisons with the rest of the array and try to find out an index at which the minimum value of the array is present and then replace with the ith index. Any questions, anyone? Shall I repeat anything?
Karthik, I have one doubt.
Yeah.
A selection sort, we just take increasing order
Your voice is breaking.
but it is the same. What is the difference between
Sorry, I can't hear you clearly.
difference between yesterday's shot and today's shot?
So in the yesterday sort, whenever you are doing in the first iteration, see after completion first iteration, what is happened? You got the minimum value of the array in the 0th position, correct? In the bubble sort, what was happened? In the 0th iteration, the maximum value of the array came into the last position, right? That means in the bubble sort, you are sorting from last position to first position. But in the selection sort, you are sorting from first position to last position. Okay. Any other questions, anyone? Or shall we go for pseudocode? Vijay, have you joined newly? Vijay Band,
Yes, yes.
is this your first class?
Yeah.
Okay. Have you seen the previous videos?
No, yesterday I missed which video you are saying?
No, this is, this demo classes are started on 6th of March. We have completed around 5 demo classes. So I'm just asking, is this your first class or have you seen the previous videos?
No, I have not seen that. I thought that this batch will be started from 11 March. Yesterday only it was started, no? Or no?
No, it is started on 6th March.
Okay. Where can I get the previous video?
Yeah, I will share the links or you can see it in the WhatsApp. YouTube. Let me quickly share it.
Oh.
So what you can do is just go to YouTube. Okay. In YouTube, just enter Ashok IT channel.
Yeah. Yeah.
Okay. Now, and then you go to this live section. Okay. Now here, do you see this advanced data structures?
Yeah.
So this is session 1, session 2, session 3, session 4.
Okay, I'll go through. Yeah.
These are the previous videos.
Okay.
Or let me, at the end of the course, let me try to, let me ping you the videos as well. So I have the 3 videos. I'm going to ping you this.
Okay.
Do you know the course content and all? Field structure at least?
Oh, yes, I know all this.
Okay. So the class timing is every day morning 8 a.m. to 9 a.m. And we are going to look at all the data structures, like advanced data structures. Sorting, searching, dynamic programming, graph, and there are so many questions of trees. And coming to the collections, we just completed the internal implementation of collections, linked list, stack, queue, and all. So if you would like to enroll for entire collections and advanced data structures, it would be 10,000. If you want to enroll only for advanced data structures, it would be 5,000.
No.
Okay. Any questions on today's class?
No. Right now, don't.
Okay. So any others, any questions? Yeah. Now let's look at the code. How can we write now? So now here, let us take the numbers first. 14, 10, 56, 1, 5, right? Let's write 14, 10, 56, 1, 5. Okay. Now these are the numbers. What am I doing first? Let us write the pseudocode. In order to write the pseudocode, first, what I thought, I'm creating one min index. I'm creating one int variable, min index equal to 0. Okay. Because I'm assuming that what in 0th index, whatever the value is present, that is the minimum value. I need to compare this with the rest of the array. So that means, can I say if, how am I comparing? Can I say a of 1 is less than a of 0? A of 0 is nothing but I'll replace it with a min index, correct? The variable, I have used it. If I do like this, what is the value of this one? A of 1 is nothing but 10. 10 less than 14. What does it mean? Is it true?
Yeah.
Yeah, if it is true, is your min index, 0th index is containing the lower value? If this condition is true, which index is the lower value containing the lowest element of the array?
First indexing.
First index. That means, can I say I need to modify this min index, correct? Min index is no longer, min index is no longer 0, correct? Equal to 1, correct? Now, Now, shall I stop it here or shall I continue? But see, now that means what is your min index value now? 1. Now,
1.
here, now shall I do AF2, I need to do AF2, correct? 56 less than 10 I need to do. But if I hard code the index as 1, will I, see, can I, if I write an if loop, can I repeat it?
No, that is
Then
for
what
loop.
should I do?
For loop.
I have to use some loop, right? So that I can execute, correct? Now, for example, for j equal to 0, j less than a dot length, j plus plus. Okay. Now, or let us take, okay, let us do for this. Now, can I say now here, instead of j starting with equal to 0, can I put min index? Okay. And min index plus 1, or I can say, or else j equal to, let us take 1. So j, let's put j. Okay. Now, if you look at here, 56 less than 10, a of j is nothing but now j is 1 is completed. Now j becomes 2. To a of 2 is nothing but 56. 56 less than 10. Is it true?
No.
No. Continue. J becomes 3. A of 3 is nothing but A of 3 is less than A of 1. A of 3 value is 1. 1 less than 10. Is it true?
Yes.
So whenever it is true, what does it mean? Earlier you thought at one index, the minimum value of the array is present. But when the condition is true, what does it mean? One index is no longer having a minimum value. What is the index that is containing the minimum value now? Fourth index, 0, 1, 2, 3, third index, correct? Now let us put, instead of 1, let's put j. Now your j value is, j is containing, so your min index is equal to, min index has become 3. Now let's continue. Now a becomes 4. 4 less than 5, true. So a of 4 is nothing but 5. 5 less than 1, is it true? No. Now j increment, j becomes 5. Now your condition, j less than a dot length, 5 less than 5, is it true? Done. So that means, can I say I have done with a loop? This, can I say that I will come out of this loop?
Yes.
Now after coming out of the loop, what is the minimum index value you got?
3.
Before starting your program, you thought the minimum index at 0. At 0th index, the value is present. But after doing the comparisons, you got the minimum index as 3. Now what should I do? Can I say I need to swap this index, minimum index 0, third index with the 0th index? Correct? Can I say I need to swap?
Yes.
Yes.
That means, should I swap within the for loop or outside the for loop?
Outside for loop.
Yeah, then because outside for loop means you will get to know all the iterations, right? After completion of this loop, I will say temp equal to a of min index. Okay. A of min index equal to a of, let us take or let us take 0 for now. Now a of 0 equal to temp. See, first I thought 0, right? So I'm hard coding the value 0. Now after doing this, after writing this swap, can I say my data looks like 1, 10, 56, 14, 5. Yes or no? This is my array.
Yes.
Yes.
Yeah. Now, shall I stop it here?
No.
If you look at this is sorted now. I have to continue. So that means, can I say that this for loop I need to continue, this swapping logic also I need to continue further?
Yes.
And what will be my min index next time?
First index.
First index. Now, what should I do? In order to repeat entire logic, what should I do?
One more
Out
for
the
loop.
loop.
That
One
means,
more
can I
for
say,
loop.
yeah, before, that means, can I say that before in min index equal to 0, I will write one more for loop, correct? Int I equal to 0, I less than a dot length, I plus plus. Is there any way without writing a two loops I can do? No. Correct? I'm closing here. Now, instead of, say, what is min index? can I, instead of hard coding the value as 0, can I put I? When I equal to 0, min index is 0. In the second iteration, I equal to 1, min index will be 1. So I will replace with I value, correct? Can I say this is my program?
Yes.
Yeah. So this is the beauty of selection sort. Do you understand why are we writing each line of code? Shall we write this quickly?
Yes, sir.
Yeah.
Now, let's create selection sort. Main method. Let us take an array 14, 10, 56, 1, 5. This is my array. Okay. Now let's write public static void selection sort. So you are selecting a value and sorting it. Hence it is called selection sort. It should take int array. Okay. Now first what I am doing, int min index equal to 0 first. See, I am not butifying the code. I am not by hearting the code. Correct. Now what I am doing, see, first I thought, what is my concept? First I am thinking that whatever the index, 0th index is the minimum value. Now I need to compare. Now what I am doing, a of 1 is less than a of min index. If this is true, that means I am doing a comparison to check whether this is a minimum value or not. If this is true, my min index will become 1. But I need to continue this one. Yeah. Are you guys able to hear me?
Yes, sir.
Yeah. Now, so I am just writing this array. Now, if I want to continue this logic, so I need to write loop. Why am I writing a loop? Because you are not stopping with one array, one element, right? You need to compare with the entire array. So, yeah. So let's take it as a J. You can take any variable, but generally we are habituated to first for loop I and second for loop will be J. So generally that is what we follow, right? So I will say that you see, you are taking with the 0th as an index. Then where you need to compare? First index onward. So I am putting J equal to 1. So let me put J. Now, J, done. So once this loop is completed, what does it mean? Once the loop is completed, what does it mean?
For the minimum index, we found the minimum index of the element.
Yeah, you found one index at which the minimum value of the array is present, correct?
Yes.
Yeah. Min index, what is the meaning of min index? The variable name is at this index, the minimum value of the array is present. Let me write here. Min index means at this index, minimum value of the array is present. First, I am assuming 0. But after doing this loop, I found that minimum index. Now, what should I do? I need to swap, correct? Int temp equal to a of min index. A of min index equal to a of 0. A of 0 equal to temp. Can I say this is nothing but a sorting? Yes. Now, so this is for a, so now after doing this, at 0th index, I will be finding the minimum value of the array. But shall I stop it here? No, I need to continue. The same thing, I need to do it for the entire array. So I am writing another for loop. I equal to 0, I less than I dot length, I plus plus. The entire logic I need to repeat. Okay. Now here, in the second iteration, what is the min index? it is no longer 0 because 0 is sorted. You will put 1. So what I will do is I. Now, in the second iteration, whenever you are taking the min index as, see here after this one, your min index equal to 1. A of 1 is nothing but 10. A of 1 is nothing but 10. So you are comparing this with what? Again, you compare with itself or you have to compare with the rest of the array? Rest of the array, correct?
Rest of the array.
So can I put I plus 1 instead of 1? Do you see the difference? Every time, if whenever I equal to 0, you are comparing with a 1, first element onwards. When in the first iteration, when after completing 0 iteration, you will go to the first index. When you are assuming that this min index equal to 1, you are comparing this A of 1 with the rest of the array, correct? That means 2, 3, 4. Now, after completion of this one, the array looks like 1, 5, 56, 14, 10. Now 1, 5 is done. Now your min index will become 2. And this 2 index you are comparing with a 3 and 4. So that is the reason, can I put I plus 1?
Yes.
Yes or no? Yeah.
Yes.
Now instead of 0, can I put I position? So that you are swapping with every time ith value. Right? This is a program. Now let's put out sys out arrays dot toString. See, if I just print an array, I don't get the output because it's an array. It is not a list, right? So that's the reason I'm doing arrays dot printout. Now since it is a static method, let me call this method and pass the array. And see, let's run the program. Run as Java application. See, I'm able to see the sorted output.
Yes.
Yeah. So this is the beauty of a selection sort. Now, when do you use a selection sort? If someone is asking you some 100 elements are given, and if they're asking you third minimum value, fourth minimum value, then do you prefer the bubble sort or do you prefer the selection sort? My array contains 100 elements and I'm asking you third minimum value of the array. Write a program to find out third minimum value. Then which one should I prefer? Selection sort or bubble sort?
Selection sort.
And do I need to do I need to execute the outer for loop for a dot length? For example, if I am asking third minimum value, how many times I should loop it, the external for loop?
3 times.
Three times, correct? If you are looping for all the a dot length, that means it is as simple as you are sorting entire array. So you do not want to sort, you just want third minimum or fourth minimum. Whatever the number, that nth minimum that they are asking, you just put that n value so that it will give you that answer immediately. Right? Any questions? Anyone?
So I may be wrong here, but what if we put that swapping logic, insert that if loop along with that min index equal to j, we will keep that swapping logic as well there.
So if you are putting this one inside, for each iteration, you are doing it, right? Is it needed? See, whenever you're doing now, if you do like this, what happens is, first, let us do the manual debug. What is I value? You tell me.
0.
0. See, when I ask you that, it does not mean that I'm targeting you. Okay, I'm just wanted to make sure that you are understanding. Okay, don't take me wrong. Now, min index variable will be
0.
0. Now, j value will be I plus
0.
1. 0 plus 1, 1, correct?
Yeah, 1. Yeah.
Yeah. Now, and what is the a dot length? A dot length is nothing but 5, correct? 1, 2, 3, 4, 5. So 1 less than 5. Is it true?
Yeah.
Yeah, then it will come here. Now, A of j is nothing but 1 less than A of min index, 0. A of 1 is nothing but what? 10, right? Less than A of 0, 14. Is it true? Yes. Whenever it is true, what are you doing? Whenever this condition is true, that means this min index, before starting, I thought 0th index is the containing the lowest value. But after doing comparisons, I found at 0th index is not the lowest value. Now, first index is the lowest value, correct? At this point of time. So my min index will become J. J is nothing but 1, correct? Agree? Now, if I keep the swapping logic within the loop, then what are you doing? You are swapping this 14. So because of this swap logic, what happens? Your A of min index is nothing but you are swapping this 14 and 10, correct? 10, comma 14, comma 56, comma 1, comma 5. But is it needed? If you're swapping it, are you going to get it anything? No, right? So again, like J value will be incremented. J becomes 2, correct? Yeah. That means unnecessarily you are swapping every time, correct? Yeah. So now J becomes 2. 2 less than 5. Is it true? Yes. Now A of J. A of J is nothing but A of 2. Okay. And what is the value of min index? It is 1, correct? A of 2 is nothing but 56. 56 less than 10. Is it true? No. That means 10 is the still smallest value. Continue. So you don't, again, again the swap logic, see, even though you do not have any change, again your swap logic will execute, correct? Yeah. Yeah. Again, I mean, the array looks like same because your min index is same and your I value is also same. Again, it gets swapped. No issues. Now, J becomes 3. 3 less than 5. Is it true? Yes. A of 3 is nothing but 1. 1 less than 10. Is it true? Yes. So your min index will become 3. Right? Now, again, you will be swapping. So that means this 1, see, 1 will come here and 10 will come here. Agree? Yes. And J becomes 4. 4 less than 5. Is it true? Yes. A of 4 is nothing but 5. 5 less than 1. Is it true? No. J plus plus. J becomes 5. Okay. Now, whenever the 5 is, the array is broken. Now, after it's broken, you see, if you are writing outside of a loop, only one time you need to swap, correct? But if I am writing this logic within the loop, even though it is not necessary, I am swapping multiple times, right?
Got it.
Yeah. I hope you understood it, right?
Yeah.
Yeah. So that's the reason you need to write. So that is what I have mentioned in the first. Compare with ith value with the rest of the array and try to find out at which index the minimum value of the array is present. And then replace with ith index. See, this inner for loop, what it is doing? Because of this inner for loop, you are comparing for that value with the rest of the array. And you're trying to find out the index at which the minimum value is present. And then you need to swap with the ith position. Any other questions, anyone? Now, at high level, can someone tell me what is the time complexity of this algorithm too? How many times this external for loop will execute?
N times.
N plus 1.
N plus 1, correct?
N plus 1.
And this inner for loop will execute? For each I value, the inner for loop will execute continuously, correct?
Yes.
Can I say worst scenario, it will execute for n into n plus 1 times? Yes or no? When I equal to 0, it will execute entirely. When I equal to 1, it will execute entirely. When I equal to 2, it will execute. When I equal to n, it will also execute, correct? Or you can say that n into n minus 1 or something, n. So can I say it will execute for n square times?
Yes.
Yeah. This condition, this entire if conditions, this also will execute n into n plus 1 n times, right?
Yes.
Yeah. This also n square or n into n. And this also n into n, right? Now, how many times this will execute? Will it be n into n times or only n times?
N times.
N times, because this is within the outer for loop, correct? I hope you are able to justify, right?
Yes.
Yeah. Now, if I take it entirely, what is the first I got n plus 1 and then n square. Now I'm writing n square as this like this. Okay, let me write in the OneNote. Here, I mean, writing the square symbol is difficult, right? Now, n plus 1, n square. And your if block is also executing like if statement, min index and close bracket. N square, n square, n square. And the this logical is also executing n. Now, if I look at n square 1, 2, 3, 4, 4n square plus 1, 2, 3, 4, 5, 5n, correct? Now, so compared, if I like same thing, if I take n value as very bigger value, then I can I can ignore this one. No, 4n square. 4 is constant value. Why am I getting 4? Because of your number of statements within the internal for loop. So if I remove this one, the time complexity of big O of n square. The time complexity is same as bubble sort. Hope you understand, guys.
Yes.
Yeah.
So from tomorrow class, tomorrow will be the last demo class, guys. So if you are interested, please do the enrollment. Have you guys got an email? Still no?
Yes, Karthik, yes.
Yeah. If you're getting an email, that's fine. If not, can you take a screenshot who did not get an email or who joined today? Can you take a screenshot of this? And if you are interested, you can do the payment on this account through NEFT transfer or Google Pay. And the fee is 5,000 for live classes, 8,000 for collections and DSA live, and 10,000 for entire course like collections and DSA. And if you pay for 10,000, you will be getting a validity of 1 year of accessing a videos. And send out an email to this email ID by putting your name, WhatsApp number, and course code is 28 advanced data structure. Timing is 8 a.m. to 9 a.m. Sorry. Yeah, correct. 8 a.m. to 9 a.m. and attach the payment screenshot. And tomorrow will be the last demo class. If you are enrolling, then you will be added to the WhatsApp group. There is a WhatsApp group that is created, guys, like this. So 28 advanced data DSA, these are WhatsApp group. So already some 19 members are there. So you will be added to this group and I will be sharing the code and notes, whatever I have prepared so far. And if you are if anybody is having any trouble in enrolling, please do let me know. And tomorrow we are going to look at a merge sort. So before going into a merge sort, we need to know what is two-way merging. That is the question that is asked in Microsoft interview and ADP or so many product-based companies. I'll be telling you what is two-way merging and how the question can be asked. Why are we learning two-way merging before merge sort? Because within the merge sort, we use a two-way merging. So tomorrow we are going to look at merge sort. Any questions?
Space complexity will be learning later.
Yes. I'll be telling. Yes. I already gave the introduction yesterday. I will take up after completion of the merge sort, I will take up that space complexity. I mean, I am not explaining immediately because you will be getting confused with the space and time, right? It should take some time, right? So that's the reason.
Okay.
Yeah.
So based on the number of loops, we can say, right, by seeing default, like if 3 loops are there, then it will be like n cube. Big
No,
O of
you
n
need
cube
to
like that.
write, yes, you need to look at the loop execution. So if you are saying I equal to 0, I less than a dot length, inside that j equal to 0, j less than a dot length, inside that z equal to 0, z less than a dot length, you can say n cube. But if the
Yes.
condition is modified, then it is not n cube, correct? I will come to that also. Like that means if you have a nested for loop, blindly you cannot say n square or n cube. So you need to evaluate the condition, correct? Whether it is executing n times or n plus 1 times, it all depends on that condition, right? I equal to 0, I less than a dot length, something like that, correct?
Yes.
Yeah. I will let you know that. There are some programs also we are going to see.
Okay.
I mean, what I meant by that is not algorithm, not sorting technique, but just like that, I can write a for loop inside a for loop or some loops I can write. And can I find out a time complexity? Yes.
Okay.
That we are going to see. Maybe not now immediately, but once we complete the merge sort or quick sort, I can tell you some random programs and how much time, what is the time complexity of that random programs.
Okay.
Yeah. Any questions on enrollment or accessing the videos, etc.? Anyone? If no questions, and if you are interested, please do the enrollment, and tomorrow will be the last day of demo. If no question, that's all for today, guys. Thank you all. Thanks for joining.
Thank you.
Have a nice day.